Hello and welcome to this tutorial on using the University of Colorado's Space Weather Technology Research and Education Center's Space Weather Data Portal for characterizing space weather events. The portal is designed to allow you to access myriad data sets available from quite a large number of dataset providers in a single interface. Our intention is to lower the barrier for you to be able to describe space weather events from their beginnings on the sun all the way until they impact the Earth. The Space Weather Portal is just that, a portal. We access data sets from other providers that are publicly available, and we provide tools that make it easy for you to identify, discover, find events of interest, discover data sets associated with those events, visualize those, and then download those data sets. Our homepage, which you will land on when you initially go to the Space Weather Data Portal, which is publicly available at last.colorado.edu/space-weather-portal. You'll be directed to our homepage, which just is a splash page. We have actually some SDO AIA imagery that we like to display on this page. We learned that Regents of the University of Colorado are who made this available to us. And we can learn some things about the Space Weather Data Portal, or I'll just try to call it the portal. As I mentioned, it's created by the Space Weather Technology Research and Education Center, or SWxTREC, as we like to call it. We just call it TREC, generally speaking. Within TREC, we can go and learn more about what TREC is all about. It's a center of excellence for space weather research, technology, innovation, and education. And we can learn about a couple of tools that have been built by TREC, the portal, which we'll be using to characterize a space weather event, and the model testbed, which we are building. It's a cloud-based testbed for facilitating your operations of models in the cloud. We can also learn a little bit about Lattice, which is the technology developed at LASP, which underlies the Space Weather Portal and makes it possible for us to access all of these data sets that are located at various and sundry data set providers and pull them together and provide a singular interface to them. It has a programmatic API so that you can learn about that if you'd like to access these data sets through your own code. We also have a tutorial section. This tutorial that you're watching right now, you may have found in tutorials, or perhaps you came to us from YouTube. Just some basic information about aspects of the Space Weather Portal to ease your transition into using it. We also have an event library. Here, one of the things that we'll discover as we're working with the Space Weather Portal is that while we're building up the characterization of a space weather event, the URL that we're looking at will become extended based upon all the different data sets that we've selected for display purposes. And ultimately, we wind up with a URL that has all the data sets that we've selected and in the time frame that we've selected, that it can be a single point of access, so that once you've characterized a storm, you can send that off to your colleagues and show them what you've found. They can take that URL and add new data sets and send that back to you with the additional data sets, describing something else that they've discovered. So that's the um, nice advantage of the event library. And we are inviting members of the community to please put together events to characterize, you know, put together a full URL to characterize an event of interest. So now we'd like to go ahead and start trying to characterize an event of interest. In order to do that, we need to select a time period that contains the event. And the portal provides some very nice uh, tools for helping us to find events of interest. When we look at the time range of available data sets in the Space Weather Data Portal, we can see that we have data sets from 1957 all the way out to present day. We can also see that we have a selector of a selected range of time. This represents the time period that we will be accessing data sets for. So we'd like to place that time period in a period of interest. We can also see that there are quite a few data sets describing data, describing that are basically measurements, well, in some cases models of space weather events, all the way from solar events through the heliosphere and magnetosphere, the ITM, and down to the Earth. So of particular interest are events that are perhaps flares or coronal mass ejections that make their way to Earth and impact the technologies that we use every day to do our daily stuff. So what kind of capabilities do I have to help me find data sets of interest? We have this event display capability, which has three sort of markers of well understood indicators or indices of space weather events. DST and KP are values that describe when an event has impacted the Earth and is impacting the Earth's magnetic field or the Earth's ring current. Solar flares, of course, are the flares that occur on the sun. So, perhaps I have some interest in what the heck these things are. Like, what is a DST? And I can see that, oh, it's an Earth-based data set. It comes from Kyoto, and I can get more information about it and learn that the World Data Center for Geomagnetism in Kyoto puts this index together. And it's the disturbance field, which is, oh, well, that's a lot of interesting detail about what it is. A little bit over my head. I'm not actually a space weather researcher, but if you are a researcher, you can learn a lot about what it is and find additional information about it through this metadata that we have for each of our data sets. So, well, let's take a look at what happens when I put DST on my timeline. See, great. All of these little markers show up based upon the level of DST that I've selected. And, oh, looks to me like if I the larger, or the closer to a positive value. I guess we can go to positive values. Looks like a DST of 75 is basically always. So we probably want to take a look at a negative DST value, and pretty sure that metadata will tell you something about that. And we can see that, yeah, sure enough, the lower we go into negative values, the fewer markers there are. So that is an indicator that there's a greater disturbance in the magnetic field. Similarly, I can use KP, which, as it turns out, goes in the opposite direction. So low values of KP will completely fill out my timeline, whereas higher values are indicators of events of significance. So maybe I can pop up here and see, well, okay, now I've got some nice markers out there over time periods of interest. And, you know, I could bring my time bar on top of it, but boy, it's a little hard to see exactly what I'm doing. So we have this intermediary capability of a time range that is a subset of the time range for all the data sets we have available. And this is kind of a nice way to get a little bit more refinement in our ability to select time period of interest. I'm going to go ahead and select a time period that maybe is, that we have more data sets for. Obviously, as we've entered into the space age and added more and more instrumentation in space to measure events, we have more data. And in fact, I'm going to go ahead and I know that what we've been particularly focused on is a storm that happened in 2015. So I'm going to go ahead and hop on out to that time period, and I see, okay, there's probably what I'm looking for. Somebody told me about a 2015 event, and it's called the St. Patrick's Day storm, and now I can see why. It happened right around the St. Patrick's Day time period in 2015. And it clearly had a low DST, and now the KP is not showing up there. I wonder what KP level that storm might have been. Oh, it looks like 8-. So yeah, it shows up on the KP index, and it shows up on the DST index pretty significantly. So it's no wonder people say that, in fact, there was quite a storm at this period of time. Being that these, the DST and the KP are Earth-based, I'm going to go ahead and make my timeline such that they're kind of at the selected time range, such that they show up kind of at the back end of that, since that's when the event actually hit the Earth. And I'm going to say maybe we go to the 21st. How about that? And I see that I'm limited to 12 days of data. That's because, generally speaking, we would like for the user to have a good experience. As I mentioned, we access these data sets from remote data set providers, and so it takes some time for us to get data sets when you select them for visualization. And we want that experience to be reasonably quick. Seconds is what we're really looking for. Certainly not too many tens of seconds, or less than 100 seconds is what we would really like to have your experience be. And therefore, we've limited the amount of data that you can get to 12 days. But that's also the case that a space weather event doesn't really take any more than 12 days to occur. It's generally speaking, just a few days from the event occurring on the sun to its impact on the Earth, in the case of coronal mass ejections. So now that I have used the portal to select a time period of interest, it's time for me to start thinking about selecting data sets to describe an event. So we have data sets. Currently, there are 71 different data sets that are generally measurements, in some cases models, of space weather events starting at the sun, passing through the heliosphere, magnetosphere, the ITM, and ultimately impacting the Earth. So events that impact the Earth will, generally speaking, pass through the L1 Lagrange point. And it happens that at the L1 or libration point at about 1.4 million kilometers from the Earth, there's this lovely instrument called ACE that measures a number of different parameters, which includes magnetic field, energetic particles, and solar wind. And I would like to just go ahead and take a look at what's happening with the velocity of the solar wind at the ACE spacecraft in the time period of interest. So right now, the data portal is going out and speaking with our backend service, asking for it to acquire the data set from the provider. In the case of ACE, that provider is NASA's SPDF planetary data facility and through their CETA web. And we're accessing the values of the solar wind velocity from that data set provider. And now we can see that we've got some very nice indicators of what the velocity is at a particular time within our plot. These time series plots are kind of a handy way. I can do some interesting things, like I see that there's a nice discontinuity that occurs here. By clicking and dragging on the plot, I can zoom in on that period of interest. I can zoom in even further and see that we had an uptick from 402 kilometers per second at 0403 to 512 kilometers per second at 0404. That is, decidedly an indicator that something big has just happened at the ACE spacecraft. By double clicking, I can get back to seeing the whole timeline for ACE. So now there's definitely the case that something is moving from the sun to the Earth and passing through that L1 point. Why don't I take a look at what might have started that on the sun? So I'm going to take a look at a solar data set. And I just absolutely love what one can see with this Solar Data Observatory AIA imagery. When I plot that, now here again, we're now going out to a different data set provider, the Solar Data Observatory. We are asking for a listing of URLs for the images that fall into the time period of question. And then we're grabbing those URLs and going out and getting the 512 by 512 images. Now, in full disclosure, I will tell you that I did preload this data set so that that timeline that you just saw of it filling in for that data set was pretty rapid. Because we already had those. So, gosh, I see, I kind of like the idea of telling the story in a timeline from top to bottom. So I'm going to grab that image data and put it on top of the ACE data. And let's see, so this uptick in velocity happened right here at this time. But it took some time for that coronal mass ejection to get from the sun to the ACE spacecraft. So I know that that took about 2 days. I mean, you can, the distance is about 100 million kilometers. So you can do the math to figure out, given sort of this velocity in here, how long it would take for that to get there. And we can say that it took about 2 days. So let's go back 2 days from the 17th to the 15th. And now we can see what is likely the cause of that spike in solar wind velocity. And right now I'm just clicking to step through individual images. It can be, maybe it's a little bit hard to see what's going on there. So maybe what I would like to do is take my options and drop this down to 1 row so I can take a closer look at what's happening. And maybe what I can do is go back just a little bit further and see. Well, this thing was definitely very busy, but one of the things that I've been learning is that coronal mass ejections that actually will impact the Earth generally come from events sort of in this region. And so I can know that, in fact, this event happened right around the morning of the 15th. And I can use my arrow keys to step through those images and see that event as it's occurring on the sun. Now I can go and select other solar image data sets, or I can take a look at a different instrument. So let me go back to selecting, and I have been told about this. I work at LASP, so I've been told about this EVE instrument, this extreme ultraviolet sensor. It has these diodes that describe peaks and values of ultraviolet radiation from the sun. And my friend Wodrowska has told me about this diode 171, which kind of characterizes when things are particularly bright in that band. And it's kind of neat that I can see that during the time period of question, the 15th at about 0Z, well, there are some peaks. If I take this peak, let's say, when I take a look at what's happening with the imagery at that peak. Well, it's not playing very nicely with me. Let's get right to that peak, and well, it's a little bit brighter right at that moment. There's certainly, it's hard to tell from the imagery that there's a, that it's that much brighter than the moments around it. But I can do things, I can find other correlations, such as this peak out here, where I can see that there was a solar flare at that moment. So the diode, the 171 diode, can tell me a lot about solar flares, which is kind of interesting. It can tell me a lot about a lot of other things, which I can learn about by looking at the documentation that's available through the metadata back on the selection page. If we take a look at, let's just scroll right down to that Eve data, and we can learn a lot about what that instrument can do and get a whole lot more detailed information, including the reference publication. So our intent is to allow you to explore more deeply into the data sets that you're taking a look at. So now, maybe it's time for us to look at some more data sets and some capabilities that are available to us in the time series plotter. I can learn about data sets that are available through some higher level searching functions. We can see that there are specific observatories mentioned here. There are instruments. And we can search just straight text to find elements in the metadata of what we're looking for. So I know that there's more information available to me in this ACE observatory. And if I select the observatory, I see that there are just 3 data sets. My whole data set selection criteria window shrinks down to just the 3 data sets that come from ACE. Looking at that, I can see that there is this nice solar energetic particle data. And having read the metadata about this SEP data, I know that these 2 bands have the largest wavelength representation for energetic particles, and so should be the most significant representatives of available particle data for the ACE spacecraft. And sure enough, I see that there is particle data that correlates very nicely with the uptick in the solar wind speeds that I'm seeing up here, and the big bump that happens there. I guess to me, it's kind of interesting that the solar wind speed big jump precedes a large amount of particles. So they're apparently pushing that wind ahead of them. And I can see the 2 different data sets, but maybe I'd like to take a look at them together. The portal offers me the opportunity to drag data sets, time series data sets, and place them on top of one another to be able to see how they correlate with respect to one another. And you can see that these do correlate very nicely, with some variation in that correlation, which might be quite interesting to study. For example, the fact that the energetic particles in the P7 data set drop below those of P8 at certain periods. So that overlay capability is something that can be quite handy, and I can pull any time series data sets into a single plot so that I can make comparisons of those data sets right there, and even expand the size of the plot, as we've seen before, to be able to have a closer look at those data sets. There are some other features on the time series plots that are available to me through these plot options. The ability to turn on and off the navigator, scroll bar and y-axes is available to me. The ability to use multiple axes or not use multiple axes for the y, to adjust some scaling, and to change the type of display that I'm looking at and how gaps are displayed. Now let's take a moment to have a closer look at capabilities that we have with the image viewer. We've seen this nice ability to see sequences of images gathered from various sources. SDO, AIA, and HMI imagery are one form of imagery at the sun, but we also have images of geomagnetic information that show up in the Earth-based data sets. So let's go ahead and clear out our search criteria here so we can see all of our data sets. We can find out what data sets are viewable in the image viewer by looking at this display type. And image data sets are viewed in the image viewer, line data sets in the time series data viewer that we've taken a look at. And for Earth-based, we do have these modeled data sets for geoelectric fields, magnetic fields, and voltage maps, which are pretty interesting. And we'll take a look at in the sun to mud story. Let's head back to those nice AIA images, and why don't we take a look at another AIA image data set and go ahead and plot that up here with next to our first one, and we'll take this plot and move it down so that we've got our image data sets sitting right next to each other. And I can go ahead and increase our number of rows to have a look-see at these two image data sets as compared with one another. Now, what we're seeing there in terms of getting the image data set is the front end reaching out to our back end Lattice instance, asking for the URLs for the data set, and then getting those URLs and downloading the imagery. And as that time bar filled in, we were getting all of the images along the timeline so that we can see what was happening in the 1600 AIA channel right there at the time when the storm is taking effect. And certainly we can see some very interesting things. I'm no SDO expert, so or AIA expert, so I can't really tell you exactly what's happening there, but I can tell you some of the things that you can do with respect to that. And one of those is to go ahead and sync the image viewers so that you can see what is happening in both images at the same time. Oh, what happened there? We had a little dropout. Well, actually, the SDO instrument the AIA instrument can have dropouts, and some of these show up as gaps in the timeline when there are actually no files available at the data provider. And some of them show up as kind of blank images, which is indicative of a file being at the dataset provider, but data being not in the file. So what else can we do with these image viewers? Well, one of the things that we might want to consider doing is decreasing the amount of time that we're looking at. We know that our storm is happening right around starting in the morning of the 15th, and it looks like if we take a look at this data set here, that it continues right out until, let's say there. Where is there? Oh, that's still the 15th. So what if we change our selection criteria to be from the 15th to 16th? Or maybe just for grins, we'll do the 14th so that we can see the onset of the storm. Notice how our time selector now doesn't even cover the event indicator because the event is at the Earth rather than at the sun. So we'll go ahead and display uh, just 3 days worth of the image data in these two image viewers, which we do have synced together, and we can go ahead and kind of run a movie of what's happened there. Maybe what we want to do actually is go ahead and loop that so that as we run our movie, we come back around to the beginning of the storm onset, and you can see that some stuff was happening on the 14th, and maybe that has something to do with an uptick in solar wind speed measured at ACE. It seems unlikely that, in fact, it's likely that whatever was coming off the sun at that time actually missed ACE and missed planet Earth. But there are other data sets that might help us to ascertain that information. These two image views are kind of tiny. One nice option that we have with the image viewer is the ability to decrease. We've seen how we can decrease the rows to have an image nice and visible, but we can also increase the columns to give us the ability to look at these images next to each other. And depending upon the aspect ratio of your machine, you may even want to go more than 2 images, but 2 works nicely in my case. And I can also expand my web viewer and have a full view of 2 images side by side as is possible. I can do other things with the image viewer, such as changing the speed at which I'm looking at things. Maybe as I come in on the storm, I'd like to go ahead and blow right by some of that. But then as I get closer to the storm, maybe I want to slow it down to be able to take a look at each of those frames a little bit more slowly. Of course, I can also pause it all together and use either these clickers here to step through the images one at a time, or in fact, I can use my keyboard left and right arrows to step through the sequence of images. I do so like that 3-channel overlay. You get to see a lot of very interesting stuff there. So there are some capabilities that we have in the image viewer that are very nice to have. All right, so let's continue to tell our sun to mud story. We now know that the event starts around the 15th, so we can just go ahead and leave the 14th as our start date and roll on out to the 25th, those 12 extra days. And so far we've selected a few solar data sets that tell us what's going on the sun. We have selected a few heliospheric data sets that tell us what's happening at the L1 Lagrange point. Why don't we take a look at some magnetospheric data sets? Now, the Van Allen probes are a set of probes that were flying. They very recently completed their mission, gathering information about electrons and protons in the magnetosphere. So my colleague has informed me that a very good set of elements for the Van Allen probe data to describe an event are in the low MEV ranges, 2.1, 2.6, 3.4, and 4.2. So let's go ahead and plot those. Oh, that's right. We had left our options such that we only had one row. I'd like to get two and get back to one column so that we've got those time series flowing very nicely from left to right. And so now we can see the onset of the event here at the sun. I'm going to go ahead and get rid of that 1600 file. A very nice feature about these plots is that you can simply eliminate them by Xing there. Of course, you also have the option of working with the plot drawer to eliminate individual variables that are being plotted. So we're taking a look at these repped electrons and at various frequencies. And so these data are a little bit more slow in loading. It takes some time, as it turns out, that the structure of those data sets at the data set provider make it a little bit more slow to get them. But we can see that something happens. Oh, interesting. You know, we can see that just prior to some moment in time, the Van Allen belts, the radiation belts, are fairly cleared out of data. And then we get a big influx of data for those belts. Now, I'm going to go ahead and plot these all over the top of one another just to see how they correlate with respect to each other and what sort of story they might tell us collectively. And yeah, they does seem that maybe we get an uptick in the second belt, the blue belt, before we see upticks in others, but and we certainly have a spike in radiation belts that then sort of dissipates. We get another spike in here, which is kind of interesting. And so we can see the kinds of things that are happening in the radiation belts. About continuing on along our journey from the sun to the mud. Well, the next zone is the ionospheric, thermospheric, and mesospheric, where we have some GRACE data. And GRACE is an instrument that was actually two satellites that flew right in series with one another. And they have an accelerometer on them that allows us to infer a neutral density adjustment, because what can happen is that as the material hits the atmosphere, it heats it, and that heating causes an expansion, and that expansion causes an increase in density at the levels of the atmosphere where satellites are flying. This is actually a pretty significant concern for the scientific or the satellite operations community. And we can see, yeah, there's definitely a heating of the atmosphere that happens. Interestingly, that happens before we see the uptick in the Van Allen probe data. And what I've learned recently is that that's actually to be expected, because these energetic particles are coming back through what's called the magnetotail and filling in sort of after the fact. They kind of go past the Earth, and then the magnetotail brings them back in to fill in the Van Allen belts. So continuing our story then, we can ask ourselves, what about impacts on the Earth? of course, we do have this DST index, which we can take a look at. And in fact, we might want to consider, now that we know that the impact on the Van Allen belts occurs a little bit later, maybe we'll want to sort of adjust how we're plotting that, and maybe move that plot to the very end, which is really simply done using the plot drawer. So here is where our DST hits its greatest negativity. Right about the same time that our atmosphere has peaked in its heating. What about other data sets? Well, the USGS maintains this whole set of magnetometer stations placed all around the United States and in some of our territories that measure the magnetic field. So we can take a look at a few of these. We can have a look at what's happening. And this is kind of interesting. There are two different stations for baro, definitive versus variation. I wonder what's going on with respect to that. We can learn about the difference between definitive and variational or preliminary, through our metadata. And so we might decide that actually we would like to stick with definitive data because that's the one that is the most, that has been thoroughly analyzed and processed and made available for scientific exploitation. So we might just pick a few stations that we'd like to take a look at. Let's go ahead and go out to Guam as well. And now we can plot those and kind of intercompare what's happening at each of these magnetometers. And nicely overplotted information, and we can start to see, well, there's definitely some distinct patterns that happen, and it turns out that has a lot to do with geography and location relative to the poles or relative to the equator. The magnetic field has variational behavior depending upon the latitude of the magnetometer station. Finally, we can take a look at that model data that we have for electric field maps. There's the magnetic field maps, the geoelectric field maps, and they've been mapped onto these voltage maps. These are some data sets that are generated actually by the TREC testbed and made available through the portal. Can learn about the model that was used to create these data sets. And then we can go ahead and plot them. And they're pretty neat in that they give us more of a, rather than a specific location indication, they give us more of a generalized feel. So in the case of the magnetic field maps, we have a gridded result. In the case of the geoelectric field maps, it is gridded, but it's based upon these stations because the geoelectric is very much driven by the materials in the soil around a given location. And the USGS has dug all of these holes to measure that impact. Both the geoelectric field maps and the voltage maps are based upon that information because it's critical to understanding of the electric, you know, how these behave. Oh, and we left our linking of these image viewers so that we can see very nicely that when when the magnetic field is affected, the geoelectric field is affected, and the voltage maps. These are kind of an indication of how much voltage per kilometer. So here we have voltage per kilometer is indicated, and that's an increase in voltage. So our grid operators are very interested in that information to inform them as to whether or not they might have a situation with respect to the grid. And like we saw in the when we were playing with the image viewer before, we can do things like zoom in on those image views. We can increase the number of columns so that we can compare side by side. And we can also adjust things around. For example, we know that we can grab an image data set and move it down below so that perhaps now we would like to intercompare the overall field with the effects on the power grid. And again, I'm using my keyboard left and right arrows to take a look at these in comparison with each other. So now that we have described a full sun to mud story that we're particularly interested in, and I think I'll go back to the option of having only one column, and we can close down that so that we can have a nice view, and maybe we can bump back up to 2 rows. Now we might have interest in downloading these data sets for our purposes locally. That's available to us through the Download tab, and we can go ahead and select our time format within the files so that we can consistently compare one another. We can choose the format of the file that we would like to have downloaded, and of course we can separately download the image data sets into their own zip files. So that gives us the ability to start working with the data locally and doing a greater degree of analysis than is available through the portal. The other thing that I might add is that if we go ahead and take a look at our view and turn our toolbar back on, we can see that we have built up a very long URL that contains all the information that allows us to do the plot that we're doing. So we can actually make a copy of that URL, send it off to a friend, and they can paste it into their browser, and it will just automatically take us to that same place, to the same data sets, structured in the same way, so that they can take a look at what we're seeing with respect to these data sets. Then the other nice advantage that that then gives us is the ability to have an event library whereby we take those URLs and we just ask our users to go ahead and provide us a description of what they've characterized with those data sets, provide us the URL, and we'll add a link to that. And then we indicate what dates the event is surrounded, the data sets describe, and we ask you for some contact information. We're happy to put up events without your contact information if you prefer to remain anonymous. And then end users can get a hold of that simply by clicking on the event link. And that will load up all the data sets that you put together in that event. You can see the time that I made this St. Patrick's Day event, we didn't have as many data sets as we do now. So the event describer doesn't cover quite as much. So there you go. That is how you tell a sun to mud story using the SpaceWeatherTREC Space Weather Data Portal. Please contact us. Let us know what you think. Our email address is right here. Love to hear from you what data sets you'd like to have us add in, what capabilities are working and not working for you. We would just love to hear from the community what we can do to make it better. We're developing it in a modality that allows us to do regular releases. And so you will be able to see consistent updates through this changelog of what have we done lately and how has it changed since the last time I was here. Well, thank you very much for your time, and please enjoy the Space Weather Data Portal.